Okay, welcome to Lecture 3 for Information System Security. Topic area is going to be lifecycle security. A couple things we'll be talking about here. Uh, security principles can be applied to improve security throughout a system. Um, the idea of the key concepts of that are supporting cybersecurity throughout a lifecycle, and then identify important software assurance and cybersecurity best practices. From a readings perspective, what we're talking about here is once again from the NIST 812. This refers back to chapters 8 and 9. A couple of videos here, um, really talking about software development lifecycle, or SDLC. So the idea is, some of the different dimensions of what we mean when we talk about a secure SDLC process. So there's a couple of different examples here. Right. So the idea of, kind of starting off this, there's for any application development, application support, there's really a set of processes that we go through. There's a couple, as we look here, it's actually not a bad model here. Model gives us, there's things kind of as we would call it here, an agreement set of agreement processes around the acquisitions of a software. Um, Project enabling processes. So the idea of a life cycle management, infrastructure management, portfolio management, quality, knowledge management. These are all different types of processes that are focused on what we do around a kind of a project focused technical management processes. So we've got project planning, decision management, risk management, configuration management, and then technical processes. So they take any number of factors: security, stakeholder needs and requirements definition, architecture definitions, design definitions. These are all different um, elements, and we these all together. This makes up what we call an application lifecycle. So there's different stages associated with this. The idea of kind of coming up with the idea, conceptualizing what you want to do, um, developing it, running it, utilizing it, supporting it, and then ultimately at the end, retirement. So everything that we create ultimately will have an end point. And we manage this kind of from sunrise to sunset. This is actually from this particular model right here is from IEEE 152.588, or excuse me, 152.88. So this is simply a model that's defined and kind of captures all the different aspects and dimensions associated with what we call as an SDLC. So from a planning perspective, the things the couple things we're looking at with this. Number one is development of a policy. A lot of what we do in security, you'll hear the term security policies and definition of policies, documentation of policies, approval of policies. Really, it's the development of a system specific policy in order to define what you want, what we need or what we want in terms of security requirements. In addition, we also want to make sure that we have an assurance that the security is appropriately considered in the system's design and operation. One of the biggest flaws that organizations have run into is that the security is not woven into this life cycle planning. So what do you end up happening is, you know, a product is designed, you initiate the life cycle, and then like about a third of the way in, or half the way in, or maybe after everything's all done, you come back and you kind of blend it. Now let's apply security on top of this. The idea, it really needs to be, the idea of security needs to be built in from the beginning, and so there's consideration of security all throughout, but just in the design process. It's not just in the development and the operation, but in the fundamental design. Um, Risk management. So the idea of security is maintained using risk management techniques. As we do is um, focuses on what are the different dimensions of risk, what are risks associated with the application, um, where do we stand at any given point in time in terms of a risk profile, and what we're doing to both reduce risk and to uh, monitor appropriate security controls. So some of the basic concepts, you know, that we associate with cybersecurity through Lifecycle is, the system security architecture, which is basically the fundamental. These are the different security aspects. These are the types of things, and this is how this works. Um, Configuration management. So configuration, if you look at you know, any technology platform, there's a lot of different kinds of settings, and which can be set to meet particular organization requirements or to establish certain behaviors. But being able to track that and manage it and kind of keep on top, basically is an essential part of a cybersecurity of the cybersecurity life cycle. Integration, interoperability, operational resilience. So the idea of that you, a working operational entity will continue to operate and does not arbitrarily turn itself off or fail. Um, Continuous monitoring. The idea of not monitoring is not once in a while thing. Monitoring is basically wired into the ongoing operation. And then finally, partner reciprocity. So some of the core principles we're dealing with here, repeatable and documented procedures. So some of the stuff is seems like it would be common sense, but you'd be surprised a lot of times how you go into an organization and say, okay, we'd like to see your what are our documented procedures for what we're doing, and people kind of look at you funny. So the idea of your core the dimensions, the things we want to see in terms of the life cycle security, repeated, documented, well documented, design, repeatable procedures, um, controls around your secure systems modification, procedural rigor, and finally sufficient documentation. Sometimes you'll see, sometimes organizations can go, you have a continuum, you don't have enough documentation, or you have, basically you document everything, but things get lost in the you know, and the volume of stuff. So the idea was really what you want to try to target is, what is the sufficient organization to meet your, sufficient documentation to meet your requirements for a particular situation. So system security architecture, referred to here as interoperability, effective management of cybersecurity, requiring adherence to system security architectures. While to basically with two objectives. Number one is you want to be able to share information, while two, understanding there's a risk associated with that, and managing that risk in an effective fashion. And it's the formal. And this is more of a formal definition. It's the strategies, standards, and plans for achieving assured, integrated, and survival information enterprise. It's pretty nice. It's a fancy definition of it, but what it is, it's basically what it is. It's the collectively all of the stuff that we've put together with the objectives, and the objective of um, having a viable, operational, as we call here, assured, integrated, survivable information exercise. Configuration management. There's a lot of different pieces, a lot of different ways. systems can be configured, different settings, different variables. Configuration management, we call CM, is it's used as a means of providing risk management. It's a risk management, risk mitigation process by which um, you know your settings are established, um, and then from that point on, and that becomes your baseline. And then from that baseline, any modifications, any changes, or is handled in an organized process. So this is, and the purpose of this is, they got, and one there's a number of different things that kind of come into the and fall into the domain of configuration management. The cybersecurity is, basically aligns with the idea of um, configuration management processes. The idea is you've got a couple different things here. Obviously, security is a piece. Obviously, operational efficiency is a piece. So both of these are kind of operate hand in hand as we're looking at this. Because really, if you think about what we're doing in an organization, we're always in the process of putting something, either installing something new, or enhancing it, or correcting it, or fixing it, or applying patches to it. Um, all these things are happening. Changes are being identified and applied on an ongoing basis. One of the big things we see at DuPont is, you know, change management. We have a meeting on Thursday where we go through, no changes are put into place without a thorough review and approval process. So the idea of configuration management is part of a well-run organization, but it's also part of a well-run cybersecurity organization. Um, if you're into, kind of want to read up on this, NIST has a pretty good guideline. NIST document SP 800-128 is focused specifically on security-focused configuration management. So, kind of the provide information around kind of what the relationship of configuration management is to cybersecurity, and kind of how this operates on on an end-to-end basis. Integration and interoperability. The idea of cybersecurity is welded into or built into systems life cycles. As we just had indicated, a lot of times what will happen is cybersecurity starts, very late in the game, or like after something has been completed. And the idea is to do this stuff correctly, it needs to be integrated throughout the life cycle, from the beginning to the end, through the entire from the conception through decommissioning. This idea of interoperability through adherence to architectural principles of adopting standards-based approach, and of how all things are kind of operate and kind of work together. With the idea of also, through this interoperability, understanding and dealing with things like risk levels, associated risk management, and understanding that the idea is that when you hook any two things together, theoretically the interaction of those should be defined between two objects, or two IT components should be done in such a fashion so that there's an assurance of how things should work, and how well it should work, and how well it should work. Because what happens when it happens is, as you connect things together, one of the things we see is we start coming up with the idea of, you've got risk. Each entity has its own kind of risk profile, and as you integrate across two components, the idea is now you've got this idea of individual risks, and then shared risks. The idea of vulnerabilities of one component does not necessarily impact the other. So the idea is you could be, you're only as good as your weakest link. So the idea is to not necessarily, when you're hooking things together, compromise both parties because of a failure in one. Talking about operational resilience, the ability for a system to resist and recover from any sort of adverse occurrences. And so the idea is you want to You want to make sure that it doesn't a system will not collapse at the first at the first disruption of anything. What you've got is a resilient. We talked about the concepts like defense and depth, and being able to have you know layers of security, layers of combines of different things. Ultimately, that's where we come into this idea of an operational resilience. No single point of failure. Uh, the idea of being able to be able to resist, recover from circumstances, potentially unexpected circumstances, without causing harm or destruction. Um, some of the stuff we see here from information services provided to authorized users whenever needed. So if you're authorized to use something, you want the accessibility. Is one of those aspect is one of those is part of what we call the CIA triad. So availability. Um, so we strive for operational resilience to maintain availability. You see conversely from a black hat's perspective, denial of service and basically uh, exploiting vulnerabilities to be able to overwhelm the resilience of an IT entity. So the idea is that for mission owners, network operators, you know, the job is the security posture, the security role should be designed so that it is uh, it can be managed, it can be made operationally resilient. And also things we have, also things like the ability to reconfigure, optimize, self-defend, recover with minimal human intervention. Producing incident audit trail and also alerting as necessary. So the idea of as incidents are occurring, if a potential attack is identified, to be able to defend, but then also fully document activities that were going on during the event, so a security administrators can come back in and kind of evaluate and perhaps even maybe reconfigure, depending upon what the outcome of that attack would be. Continuous monitoring, this idea that in order to see what's going on, to understand, be able to effectively run something, you have to be able to watch it. So, um, so as we call it here, ongoing awareness of information security vulnerabilities and threats, and the purpose of supporting operational risk management decisions. Partner reciprocity relates to the idea of different partners that that different organizations will establish agreements between different organizations to accept assessments and to reuse kind of best practices and share information regarding security. Um, the idea of the essence is really to be able to deliver and efficiently and rapidly as needed um, by evolving or changing security requirements. So a lot of what we'll see here is testing, assessment, documentation, if done by independent. So one of the things we'll see sometimes is the idea of who should be under who does the validation. So the challenge you see sometimes with organizations is, okay, do you want the organization that's responsible for uh, for writing something to also be tasked with certifying it, versus actually having it done by a third party independent. So that's an area of potential, from a partnering organization, cross organizational perspective, having a third party independent certification is something that gives us, is validation, as opposed to just simply everybody does their own thing or whoever writes it says it works. Security assurance. The idea that things are working the way we say they are, particularly with security, is are our securities measures in place, operational, and providing the type of support and protection that are expected. Begins at it begins at the beginning and it ends at the end. So the idea is at the beginning of the process, the whole idea is to start understanding and evaluating, what are the cost effective security assurances or security protocols, and then to build an assurance program that matches to that. Um, Implementation includes all the different components: design, development, installation, and ongoing operational. So where we'll see things like operational audits, operational monitoring. So we're constantly, as we build this thing, we define it, we understand what we need to things to do for it to be assured, and then we support that all through the ongoing operational execution. Software assurance, the idea of cybersecurity is built um, into a system, from the ground up, instead of being something bolted on from the outside. I think, a lot of times, the challenge is, we'll use it as an example, the internet. The internet, the original design of the internet did not have, was not, designed to be, intrinsically secure from the ground up, at least kind of with the version with IPv4. So what we've seen is a whole rise of new technologies that were kind of associated with putting it onto the internet. But there's been a lot of effort to make things, to add additional security capabilities to something which was not necessarily designed up front. What we're seeing is with IPv6, a big change in the way security is managed. IPv6 is designed from the ground up to be a more secure communication protocol. So, from a software assurance perspective, what it is the definition of the different kinds of approaches, tools, guidelines, principles that goes into the development of an application, with the goal and objective of building security into it at every phase of it, not after the fact, not halfway through it, but all the way through it. So there's a couple principles here, that should be adapted. Dependability. Um, what is supposed to be done is done. What it's supposed to do, it will do. Um, it will execute as defined, as intended, with the objective, with the functional requirements say it would be. Resilient survivability. That it does not have a single point of failure, and that it will, functionally, it will continue to operate uh, even if it's attacked. It will, provide resilience around that, minimizing negative impacts. Conformance, make sure the implementation, the procedures that were applied for development were followed through. Trustworthiness, which is the idea of no exploitable vulnerabilities or malicious logics exist in the software, either intentionally or unintentionally. These are the core principles that really get used when you're developing software from a security perspective that needs to be baked into it. Testing certification, the idea is that nothing should be assumed to be operational, to be secure. Testing is required. Testing quality is built, as implemented, and is operated. So, it's an ongoing, continuously evaluating and testing and probing and determining functionality. So things we'll see is things like penetration testing, where you'll hire an outside party to try to break into your network, and then identify and correct issues as they are identified. And certification is testing different products against requirements. Sometimes certification is actually done by third parties to verify that there is no bias or that it was done properly. The idea is not, you want to have it done by somebody who's not directly involved with building of the system. And that is everything that we're going to be talking about dealing with security lifecycle planning processes.